All right, I'm out in the field on this one. It's a 2005 Chevy Trailblazer with a 4.2 liter engine. And I have the opportunity to show this, so I'm just gonna do it very quickly. I've shown in the past how to do injector balance tests using a timer tool. In this case, on this vehicle, we can actually do it with the scan tool. So I wanna show that very quick. I'm going to my engine management system. My key is on. What I'm gonna go to is my functional test menu. And you can see under the menu here, we have injector balance as an option. And what this is gonna do is the computer's gonna do everything for me. It's gonna run the fuel pump, it's gonna shut the pump off, and it's gonna fire each injector for an exact interval. So we hit continue, and it tells me to, it's saying, please note each injector can only be pulsed once per ignition cycle. And the reason for that is it will not allow you to hydrolock the engine. And so we hit continue, and then we do each injector. My fuel pressure gauge is already connected to the rail. And what we're gonna do is we're gonna pick injector 1 first. And you see when I picked it, that it pressurized the pump, pressurize the system, then you hit continue and it's going to fire the injector. So watch your number, and we want the same numbers for each injector. Not sure if you heard the injector clicking with all the car noise in the background, but that was injector 1, and we hit continue, and then we go back up here, we hit injector 2. You see injector 1 is missing. It won't let you do it again. So it's running the fuel pump now. Fuel pump just shut off. So we get our rest pressure. We'll do the same test. What we want is the same numbers across the board. Hit continue. Notice up here, injectors 1 and 2 is now missing from this list. Remember, because you can only do it one time for each ignition cycle. You would want to run the car, shut it off, exit this mode, go back in if you felt the need to do it again. Injector 3. Again, the computer's doing all of this. It's turning the pump relay on. There, it just shut the pump relay off. I hit continue, and the computer driver is actually the timer. It's gonna fire each driver the exact same interval, and what we wanna see is the same pressure readings across the board. I'm on to number 4 now. Hit continue. To injector number 5. Again, pressurizing the rail, shutting the pump off, record your rest pressure, and continue, and record your pressure afterward. Last injector, number 6. Pump's running, pump's off. You would record your rest pressure, which looks like about 58 PSI roughly. Hit continue, injector's firing, and we went down to about roughly 42 PSI. So that's it, an injector balance test done with a scan tool and a fuel pressure gauge. Well, it's a really nice test when it's available. All right, this is a 2005 Chevy Trailblazer. I'm gonna try to do this one quick. I'm in the field here. This is the one I did the injector balance test on with the scan tool. And of course, the reason I chose doing that in the first place is it was a very easy way to identify that the number 6 injector was working. Being that I can't get to the number 6 injector on this is a very, very difficult engine to work on. This is the intake, and the injectors actually sit underneath. You can kind of see the fuel rail. Can't really get a shot of it, but number 6 is way back there, and I can't get to it. Now I probably could get to the harness, but I was thinking of the easiest way to check the injector. And of course, the reason I went there first is this thing has a misfire, number 6 cylinder misfire, and you look at the scan tool, number 6 is a current miss. It's consistent. It's there all the time. It has a trouble code for number 6. It also has a map sensor trouble code too. But my focus again, number 6 cylinder. I apologize for the camera work here. I gotta show you this one. This one's pretty cool. Somebody's been here. Somebody already put a coil in it. Somebody rewired the coil too. You see some new wires back here for the coil. So the coil's been replaced, the plug's been replaced. Now you see why I went after the injector first. I did a clear flood crank. It cranks fine. I didn't hear a compression problem, so I went injector first. And now I am doing ignition testing. Now, just a little bit briefly on this ignition. It's a 3-wire coil. And what that means is the transistor is part of the coil itself. So what we're gonna have is a steady ground on one wire, a steady power on another, and then we'll have a pulsed control wire from the computer, probably going to be about a 4-volt on-off square wave that controls the base of the transistor for this coil. So what I want to do first, and what I did actually, is put an amp probe on all 3 wires, and just using a low amp probe set on a 20 amp scale, I'm going to clip this on each of the 3 wires, and I'll get you on the screen. All right, that's on the first wire. The green trace is my amp probe, and you see that I'm just barely off of 0. The number's 0.33 of an amp. What we're looking for on 2 of these 3 wires is we're looking for a coil current ramp that's going to exceed probably 8, 9, 10 amps of current flow. There is nothing on that first wire. And just to save you guys some time, again, I'm out in the field. I got all kinds of noise and light and wind, and this is horrible conditions, but all 3 wires are showing me the same thing. There is no amperage on any of these. So our concern here is either a ground problem, a main ground problem to that coil, a main power problem to that coil, or the computer is not turning this coil on and off. So we need to do a voltage measurement now on all 3 wires. All right, I apologize here. I misspoke in the last segment. I said the green trace was my amp probe. It's not. The yellow trace was, of which I have 0 amps on, so apologize for that. Same thing still, no amperage on any of the wires. The green trace is my voltage waveform, and you see on this one wire that I have a nice turn on and off square wave occurring with a max voltage of 4.8 volts. Here, let's reset that and make sure that's what we got here. Yep, 4.7 volts. So it's a 0 to 5 volt square wave. And what that means is the computer is trying to turn this coil on. And so our concern now is the next 2 wires power to ground. I have a good turn on control signal. The computer's fine. The wiring's fine from the computer to this coil. Got to do power and ground next on the coil itself. Okay, I moved my test lead. And again, it's the green trace is my voltage. And I'm reading 0.33. Let's reset that again. So you see min-max voltage, getting some spikes in there, but voltage is 0.33. So basically nothing on that. If that was a coil ground, that would be a good ground. Go into the next wire. Of course, I don't know which wire's which. Somebody was here and rewired this thing, so I'm not sure by wire color if that's the power or ground. This may be our problem, I don't know. Go into the next wire. All right, so this is the last wire, and this one's even less. I got 0.03, basically negative. So there's nothing on this wire. I'm gonna guess that one's the ground, and the one that was reading 0.33 was my power feed. So the problem with this car, the misfire with this car, is we have a broken power feed to this ignition coil. Now we gotta find it. All right, we are where somebody was in the past, as you see with the new wires here. I'm not sure why people don't just do simple voltage measurements, but this is my power wire. That was the one that was reading 0.33. I'm concerned about this area in here for sure. So I'm just gonna come back here. I have the key on, the engine's off. I am using a piercing tool. Not the greatest thing to do in the world, but you know, we'll put some electrical tape, liquid electrical tape on them when we're done on the holes we make. But I'm in this wire now, behind this splice. I'm worried about the splice take a look at my green trace. Here, I'll turn the yellow one off. My green trace is my voltage scale. And again, I'm so sorry about the camera work here, guys, but this is a good one. I want to show it to you. See, I'm reading 0.38 of a volt. There's nothing there. I'm going to move this line down. And here's what I don't know right now is maybe this system is one that doesn't send power to the coils with the engine off, and I'm going to need to run the car. I really don't want to run it with the mass airflow out because it's probably going to run pretty crappy. Although there's a way around that. You disconnect the mass airflow and it'll go into a default mode on these GMs. But what I'm going to do is check a known good coil on the same pink wire just to see if I have power here. And I do. So you look at my screen, I'm reading 12.6 volts. So we have a problem in this harness. This should not be hard. I mean, if I have power right here to this coil and nothing to this one, there has to be a splice problem right in here. So I'm gonna find it and then I'll show it to you. All right, so someone was here before me and I just took this cover off right here, but this stuff all was exposed. So someone's been chasing a wiring problem. I was surprised to find that the splice wasn't up in here. It actually goes back further. So I'm pulling on the wire that I'm missing power to. And really what you do when you're tracing these is you just simply move down the line and you take voltage readings along the way. So I'm gonna take one right here and see what we got. If we have voltage here and we don't up at our coil, then our open's in here. So I'm right here now, still have 0 volts basically on my voltmeter, and I'm gonna keep moving down the line. That is not where my problem's at. So try to do this live here. Just pulling on the harness, trying to follow this wire. It's this one. And follow it some more. And what we want to try to do is get it as far as we can. And I'm kind of moving the harness, and so it's actually this wire way down here. Sometimes a little tug is going to find it too. I'm going to do the same wire down near the source, which is the power distribution box, it looks like. Take a reading down here. Just doing some voltage drop measurements, guys. And again, I got 0.38. So my harness from right here all the way up here, all the way up to the injector is good. I need to move that direction, that way. And I'm coming close to the power distribution box. So my problem really, we're limited to right here, into here, and into the power distribution box. I wish I had my tripod so I could show you me doing this, but I'm gonna have to open that up, see where we go next. All right, so this was my last location that I measured, and I changed my scale here on my meter. I went to a big giant screen instead of zooming in on the scope. Really no reason to scope a voltage problem. You can see here in this picture I have 0.01 of a volt, and what we want to do is we want to follow this harness, and I'm just doing visuals on it as I'm coming up to the power distribution box. You know, just doing a visual first, and actually I see the problem in the wire. See if I can show it to you without breaking it. I've done these before for you guys. There is damage right here on this power wire. And what I'll do is I'll get a voltage reading here and a voltage reading here and show you that drop. Right now my key is still on. I think I left the key on. Hope I did. Kind of ruined this. And what I'm going to do is I'm going to clip on this before this break in this wire. We'll get a voltage reading here. This might snap in the process. And did I turn my key off? Oh, in the wrong channel here, sorry. When I changed my over to a digital, I'm using channel 2 for my voltmeter. I need to move my leads up top. So let's move the leads little things to consider. There's my voltage, 12 volts on that wire, 12 volts on that wire before the break, and of course after the break. I know what you guys are thinking, man, you're putting holes in the wire. I'm gonna fix the holes, don't worry. There's our 0.38 again, 0.39. So man, people put a coil, a plug, they're ready to do injectors, they rewired it, and what, never did a voltage reading? Pretty simple. Got a break in the wire, it's right here. If I pull on this, it's gonna snap. There it is. We've seen those before. Let's fix the wire, and I'll show you what the amperage pattern should look like on this ignition coil. Crazy. All right, there's my fix. I used a crimp connector with a heat shrink style crimp connector. This is one of the good ones though. It has like an epoxy that comes out of the ends when you heat it up. So it's completely sealed. We'll put a little bit of a liquid electrical tape over the little holes I put in this power wire because they'll corrode too. And I'm gonna put this harness back together, give you one last shot of this ignition coil and that current ramp pattern that I was looking for in the first place. Just to review real quick on what I did with this, number 6 cylinder misfire with a map sensor code. Wasn't worried about the map code with a dead miss. That's going to affect your engine vacuum, so I believe they're related. Owner thought he had an injector problem. I went in that direction first as he told me. He changed the coil, changed the plug, did some wiring. We did the balance test, and the balance test showed that the injector was fine. So then I went after the coil. Actually, I did a relative compression crank test. Compression sounded good. Went after the coil, found no power, no control first, no amperage to the coil, and then we found no power to the coil, tracked it down to a break in the wire in a harness that really had nowhere that should have gotten damaged. I mean, that was inside of this conduit. So I'm really not sure what caused it. There's no evidence of any other wires that have chafing or anything to them, so I don't know. I'm gonna put it back together. That is a fix. I'll give you an after result. Again, I'll show you that pattern. We'll listen to the engine. Should be a lot smoother now. All right, apparently I misspoke again on this one. This is apparently not a mass airflow engine. This just has a map. So I didn't have to worry about running this with the air tube off or unplugging the mass airflow, putting it in default mode. I don't know if you can hear how much better this engine's running. In a case like this though, don't panic if it misfires for a minute or so after a fix like this, because you have to remember that the cylinder is fuel fouled. The plug's going to be all wet, and you get a little bit of mist for a little bit. That kind of brings you to another point too, is the catalytic converter damage that probably occurred with this misfire. I'm not sure how long he drove it that way, but certainly is a consideration that the cat could be plugged up, and that could also set some map sensor trouble codes with the wrong back pressure in this. But we'll go back to the scanner, show you my misfire data on the number 6. It is at 0, and actually my map too, I didn't look at that before, but 9.8, that's subtracted from 29, so basically we have 20 inches of vacuum on this engine. I have no problem with that. That is a fix. One last thing I'll do is take my amp probe, again set on a 20 amp, and the way this works, these coils, these 3-pin coils, I'll show you one of the front ones. You see the heat sink here, the transistor's actually inside of here. So you cannot view coil negative voltage or coil primary voltage on this type of coil because the transistor's inside. The only thing you can see is your steady power, your steady ground, and then your on-off 5-volt square wave the computer uses to turn the base of this transistor on and off. So when you do coil primary on these, you almost have to use an amp probe because it's the only way you're going to view the control of that coil other than looking at the computer's small base circuit signal. So power or ground, it does not matter which one. Clip your amp probe around it, 20 amp scale. Take you over to the scope. Okay, in this last part I had to cut out the audio due to excessive wind noise. So I'm just going to talk over this last part. What I've done in this first section is connected the amp probe to the power or ground of the coil after the repair. We're looking for a ramp. And what we just saw right there was a ramp that went past the screen very fast. So time base is important. I'm increasing time base here, looking for repetition. You see the spikes actually don't look even here. And what I've done in this next step is I've increased the sampling rate. And now you can see that wasn't a coil problem, but it was a scope issue. So we see what we're looking for now. We've got about 10 amp spikes here. This is what we wanted to see in the first place. I now want to see detail, so I'm changing my time base again, dropping back down. And I'm going to set up a trigger so we can see this at an exact point on the screen. This is the coil firing in the same position over and over again. Very nice detail there. We definitely have coil control at this point. This is what we wanted to see in the first place. If we saw this in the first place, we would have gone in a different direction, maybe towards a compression problem, as this would have indicated we had spark and we checked fuel previously, so we probably would have done compression at that point. But this is definitely a fix. That's a good looking ramp. And the last part of this that I'm going to talk about here is just the harness itself. And where this customer had taken all this stuff apart. And certainly this is not a good repair. We can't let this vehicle go like this. This needs more conduit put in place. You can see this pink wire and this yellow wire running through this metal strap. That's not good. And you can actually see a little bit of damage on that pink wire right there. That's going to need to be corrected. So I'm making the customer aware of that. And the other thing that we want to warn this customer of is potential catalyst damage from this misfire. I was told that he drove this for a long period of time this way. So, of course, a good test drive would be in order here to see how the car performs. And then, again, warn him of a possible cat damage. But that's it. Misfire is gone. This vehicle is fixed.